Welcome to myprojectbazaar.com. Let me discuss about the process half-quadratic-based iterative minimization for robust sparse representation. Let me discuss about the process half-quadratic-based iterative minimization for robust sparse representation. We propose a method of face recognition which is based on half-quadratic minimization. It is an L1 regularized error correction method. It will lead to the high accuracy face recognition. Initially, we train our database images. For that, we extract M estimator features, and the process is tested using a single image. For testing, we apply the Gaussian filter to remove the noises from the input image. Then we extract the sparse-based features based on M estimator. Then the extracted features were classified using sparse representation classifier. Gaussian filtering is often used to remove the noise from the image. We use the Wiener function to our input image. With a Gaussian filter is a windowed filter of linear class by its nature and its weighted mean. Sparse representation classifier gives potentially a large set of input patterns. Sparse coding algorithms attempts to find a small number of representative patterns. In high HQ minimization, the half-quadratic reformulation of an original cost function has two forms, the additive and the multiplicative forms. Based on this, the face images were recognized and the person is correctly identified, and then we compare our results with the existing process. Let me see the flow of the process. Initially, the database that containing numerous images having the images of different persons is trained by extracting features for them. So before that, pre-processing is applied to all the images and then features were extracted, and based on that the labels were generated, and this is the training process. So we test this process by using a single test image. So we take the test image and then we apply pre-processing to it. So we resize the image to a constant size, and after that we apply Gaussian filter to it. So the Gaussian filter removes the noises in the input image. Then after that we are extracting the half-quadratic features, and that which is based on the multiplicative form. Then after the feature extraction has been completed, both the test feature and the train feature were given to the sparse representation classifier. So the classifier identifies the test image based on the feature values. So similar images have similar feature values. So based on this sparse representation classifier identifies the similar image which is related to the test image that we have given from the dataset. So thus we have obtaining the result, and after that we move on to the analysis process. In the analysis process, we measure the performance of our algorithm. This is done by calculating the sensitivity and specificity of the classifier that we are using. We are comparing this with the existing system, and we can conclude that the proposed system, which is based on the sparse representation classifier, produces better recognition rate. Let me see the execution of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface needed to run the program. Click on training data. So the data will be trained, that is the features were extracted for all the images in the data. The features were extracted and they were displayed. Then after that, select any one of the input image which is given. So we have selected this image. Then in the pre-processing operation, we are resizing the image and we are applying Gaussian filter to it in order to remove the noises in the image. So we have applied Gaussian filter and then we have resized, so the pre-processing process is over. Then we move on to the sparse extraction of the sparse features. So we are extracting that. So the sparse features were extracted. After that we are recognizing the person from the data. So as you can see, the input image is recognized, the exact person from the dataset is retrieved, and the person is identified as second person. Now we perform the analysis of the process. So here we are comparing the existing and the proposed method in order to find the analysis. To measure the performance, we have drawn the ROC curve for the classification process. So here it is a plot of false positive rate and the true positive rate. After that, we have compared the sensitivity and specificity of the existing and the proposed system. So these are the graphs for that. So thus we are providing a method that recognizes the exact face images and identifies the person in the dataset using the sparse representation classifier. So if you want to know more about it, click on about. Then after that, if you want to exit, click on exit. Thanks.